In this video, we are going to be studying extensively about the quadratic equation, the nature of quadratic roots, the method of solving quadratic equations, and the symmetric property of quadratic roots. So let's dive in. So here we define the quadratic equation as the special case of the polynomial function where the highest power of x is 2. X is the variable, the highest power is 2. And we stated it like this: p of x equals to this is a polynomial function, but in this case now the highest power of x, which we refer to as n in the polynomial function we did, is what? 2. So this is just the general representation of a polynomial function that is a quadratic equation. So we know the general form of a quadratic equation is written as ax squared plus bx plus c equal to 0. Any equation of this form is basically an example of a quadratic equation. You can have something like, let's say, 5x squared plus 6x minus 3 equal to 0. So in this case now, the coefficient of x squared is a, which is 5. In this one, the coefficient of x is 6, which is b. This one, the constant term, this c, is what? 3. So this is an example of quadratic equation. Even something like this, x squared plus 3 equal to 0. This also can be seen as a quadratic equation as well, because the coefficient of x squared is 1. The coefficient of x in this case is what? 0. So this thing can be written as x squared plus 0x plus 3 equal to 0. So you see that when 0 multiply x, this particular component vanishes. So any equation or any polynomial function you see where the highest power of the variable, which is x, whether it's defined in terms of x or is defined in terms of y, one of the highest power of the variable is 2. It is called a quadratic equation. When it's 3, it's called a what? Cubic equation. So there are different methods of solving quadratic equation, which I believe you may be familiar with, and we are going to look at them shortly. So if we have a quadratic equation of ax squared plus bx plus c equal to 0. So we can solve the quadratic equation by completing the square by the general formula, which we refer to as the almighty formula. We can also solve by factorization, and we can also evaluate the solution for graphically. The idea is to get the roots that satisfy the particular condition of that quadratic equation. So I believe you know the almighty formula, which we refer to as x equals to what? Minus b plus or minus square root of b squared minus 4ac over 2a, right? We call it the almighty formula, where this almighty formula is actually gotten from completing the square, which we are going to see here now. So if we have something like this now, that's the general case of the quadratic equation, and we want to complete the square to show you that the almighty formula is actually gotten from the completing square method. So first of all, we write it in this form, that is, we divide through by a over a, okay, which equals to minus c over a, and we transfer the constant term. So when this one crosses here, it becomes negative, and we divided through by a. So now this is where the actual work comes to play. What's the main work here? The main work is by adding a factor. That factor is the square of half the coefficient of x. So this is what I mean: x squared plus b over a x plus half. Half means b over 2a, that is 1 over 2 times here. So raised power of 2 equal to minus c over a plus the same factor here, b squared over 2a, all squared this way. So since we added it to both sides, see that nothing changed in our equation. When this one comes here, it cancels this one. So our equation is just the way it was here, and you see the same way it is here. So from here now, we can see that this particular side, this left hand side, can be written as a perfect square. For the sake of clarity, we can try to express this plus b over a x plus b squared over 4a squared, because from the rule of indices we have minus c over a plus b squared over 4a squared. I mean, when we perform this square operation, it affects both terms. So 2 squared is 4, and a squared is what? A raised to the power of 2. So from here we can see that we can factor out this thing. And when we factorize, what do we have? X plus b over 2a square. When we expand this square, we see that we are coming back to this, and this is actually the completing the square. So we have completed this square by writing this guy as a perfect square. The left hand side now is now a perfect square. When we take the square root of this expression here, we'll not have a decimal, we'll have like a whole number. So this is equal to, the LCM of here is 4a square, and from here I have minus 4ac plus b square. So from here now we can take the square root, because we're able to express this left hand side as a perfect square. So we can clean and take the square root. So we have that x plus b over 2a all squared is equal to minus 4ac plus b squared over 4a squared. So we can try to take the square root of both sides. We'll take the square root of this, we take the square root of this, either plus or minus. So this one will take away this, because the square root of a square is same thing as saying a square times 1 over 2. So this is what square root means. Square root means square root of a means a raised to power 1 over 2. So this we cancel this. That's what happened here. So when this cancels out, we have that x plus b over 2a is equal to, now if we decide to rearrange this, we have b square minus 4ac. You can see that it's taking shape over 4a squared, the square root of everything plus or minus. Now from our surd, we know that surd a over b is equal to surd a over surd b, right? So when you look at this denominator, you see that this denominator is a perfect square. We can take the square root of 2, square root of 4, and square root of a square. So we have what? 2a. We'll take the square root of this expression combined, so that we have x plus b over 2a is equal to square root of b square, remember, plus or minus 4ac over 2a. So we decide to make x the subject now. So we have x equal to, when this one crosses, it becomes minus b over 2a plus or minus square root of b square minus 4ac over 2a. So you see that they have common LCM. So we just finally conclude that this implies that x equal to minus b plus or minus square root of b square minus 4ac over what? 2a. So this was our almighty formula. This is how to derive the almighty formula. So this is basically a product of completing the square method of solving quadratic equation. So I'm going to give some example of quadratic equation and solve them using the almighty formula. Then we go into factorization of quadratic expression. Now you have to note, some quadratic equation may not be factorizable. That's why this guy is called almighty formula. If it's not factorizable, you can handle it here. At worst, you get a complex root. So let's quickly solve some problems relating to this almighty formula. So if you have 5x squared plus 3x minus 6 equal to 0. So this particular expression can be solved using the quadratic formula by substitution. The formula for quadratic, you know, is equal to minus b plus or minus square root of b square minus 4ac over 2a. So in this case now, a is equal to 5, b is equal to 3, and c is equal to minus 6. So we can just substitute it here. So now we have the value of x, which is the root of the equation, is equal to minus 3 plus or minus square root of 3 square minus 4, a is 5, c is minus 6 over 2 times 5, which is what? 10. So I have x equal to minus 3 plus or minus square root of 9 plus, we'll have here as 120 over 10. So this is equal to minus 3 plus or minus square root of 129 over 10. So that x is equal to, square root of 129 is, square root of 129 is 11.36. So we have minus 3 plus or minus 11.36. Take note, I said 11.36, not 11.36, because this is decimal over 10, so that we can have one of the solution as 8.36 over 10, which is equal to 0.836, or we can have it as minus 14.36 over 10, which is equal to 1 minus 1.436. So these are the values of x that satisfy this quadratic equation. Now note that some quadratic equation like this one now, we cannot factorize it. But before I say more on that, let's look into factorization of quadratic equation proper.